Okay, this is lecture 12. It's called Solutions in Stoichiometry in the syllabus, but it's more specifically molarity. So we'll start with slides. Most of this video is going to be working through problems because really that's what we do with molarity. So I'll show you all different kinds of problems that we work through and that you will get in your ALEX, on exams, just actually in life. What you're going to learn now, we use all the time in the lab. So solution stoichiometry and specifically measures of concentration. And our primary unit, is molarity. And this is a great equation because it can be rearranged to solve for molarity if you have moles and liters, to solve for moles if you have the molarity and volume, or to solve for volume if you have moles and molarity. Because often we have two of the three, or we can get to two of the three. So we are going to work through a number of these problems. Again, like the other math problems we've done this week, the more you do it, the more familiar it will be, the better you will get at it. And again, I highly recommend you paper and pencil over and over and over and over. It will give you muscle memory. It will fix a routine in your brain that becomes more and more comfortable. All right, so I'll go through a couple slides, then I'm going to go straight to the whiteboard. This is your core equation. Molarity, capital M, is moles of solute over liter of solution, or moles over volume. Okay, so we use a capital V for the volume at the bottom. I can rearrange this to solve for moles of solute by moving my V up here. So molarity times volume will give me the moles of the solute, what's being dissolved. Remember, solute is what's being dissolved. Solvent is what is being dissolved in. And most of what we're going to talk about almost exclusively is aqueous solutions where the solvent is water. So something's been dissolved in water. And we're all familiar with sugar or salt, or I don't know what else can be dissolved. Colored powders dissolved in water. You know, you're making your drink with those colored powders, lemonade powders, whatever. That's all molarity can be determined with that. So the moles in that case would be your drink powder. You can also solve for volume. If you don't know the volume, but you know what concentration you want, and you know the moles, or you can calculate by your mass. So we just move the V up here and the M down there, just rearranging your equation. And you can solve for volume with the moles of solute over the known molarity, all right? You have to be given the molarity for this one. So this is really about, you're going to be given information and you decide how to use that information to answer the question that is being asked. So a reminder that the way we use molarity, right, moles over volume, is very much the same way we use the molar mass. Molar mass is moles over grams. So molarity is moles over volume. Our molar mass, which you've gotten now used to using, is 1 mole per grams of something, or grams per mole of something, depending on how you flip it. Okay, so these slides are in module 8. This is 8C, solution stoichiometry, and I'm just going to start working through each slide. So when you go back to look at this, I'm just going to go down the individual slides and the problems on there. Let's see. And then I'm going to go to another concept after I do my molarity, which is dilution. Hang on, I'm looking to see if I want to make that a separate. Yeah. Okay, so. All right, so now go to the whiteboard. Okay, so across the top, and hopefully I'll have room to keep this up here. This is the core. And if I don't, write these down on some paper yourself. So if I have to erase them, you still have it in front of you. it's just for a quick reference. It really helps. So our molarity is moles a solute. In fact, I will have to erase this. So I'm going to write this up here. You write it on your own paper. Remember, the volume is the whole solution. It's not just the amount of liquid that you measured out, because if what you're dissolving, for example, sometimes when we make solutions, we have to use so much of our solute. Sometimes the amount that we add is huge. I can't think of an example at the moment. And so it actually can increase the volume. You know, if I measure 1 liter of water and I add 500 grams of salt to it, I'm actually going to have more than 1 liter of water. So we don't do it that way. You put some water in your graduated cylinder, you add your measured solute, and then you bring the water up to the, let's say, the 1 liter mark if you're making a liter volume. So that's why the volume is for the entire solution. You decide how much you're going to make of it, and that's your volume amount. And so we write this as moles over liter, or moles over volume. Remember that for molarity, volume is liter. You can also rewrite this. I can solve for volume by rearranging my equation and the moles of solute over the known molarity. You're generally given molarity. And then the third way is we can solve for mole by rearranging volume times molarity. And again, remember, this volume has to be in liters, because that's the definition of molarity. Okay, so write these down somewhere, because unfortunately I have to erase them so that you have ready access to them. Because if you have these written or you rearrange them when you're working your problems, it helps to go, oh, I'm looking for this. What do I need? I need volume and molarity. Do I have it? Oh, I do. Plug them in. There's your problem solved. So maybe I can keep this one up here though. So molarity equals moles over volume, and I'll say in liters in parentheses as a reminder. So let's go to the first problem in the slides, and it says we're going to calculate the molarity. Remember, write down what you have and what it's asking for. So what does the first problem give us? It says we're looking for molarity of a solution prepared by dissolving. So that's the solute. If it says it's dissolving, that's your solute. 11.5 grams of sodium hydroxide. Let me enlarge this. And it gives us the molar mass, which is convenient. Otherwise, you have to go add it up from the periodic table. So that's 40.00 grams per mole. And then it says enough water to make 1.50 liters of solution, which means my volume is 1.50 liters. So whenever you see in enough water to make, that's because we bring the water up to that level after we've added our solvent, our solute. So they're asking for molarity. All right, well, here's my equation. To solve molarity, I need moles over volumes. Volume, I have volume. I don't have moles, but I do have grams. And from grams, I can get to moles. So start with what you have. In this case, we have to convert this to moles. And that's that good old molar mass. And it's over here, 40 grams per 1 mole. That will cancel out my grams. That gives me moles. And so I do the math, and I end up with 0.2 0.88 moles of sodium hydroxide. Now this is 3 sig figs, this is 4. So we're going to go with 3. You can continue with extra digits if you want, because you're not going to fully round up until the end. That's a personal choice. I'm taking it from the slide, so they went to 0.288. So now I have my moles of solute and I have my volume. Now you just plug and play. Molarity equals, because that's what we're looking for, moles, 88 moles of sodium hydroxide over 1.50 liters. It's already in liters, and that's what we need. There you go. What does that equal? 0.192 moles. Molar, its molarity is a 0.192 molar sodium hydroxide solution. That tells us that we are in a solution. That is purely a solution unit. So anytime if you're reading a scientific journal and you see something given as that, you know immediately it's a solution. And most of the time it's an aqueous solution. For example, if it's sodium hydroxide, if it's not, it will say in ethanol, or it will actually specify if it's in something other than water, because it's most commonly in water. Okay, so that is that question. So the next one. The question says, how many mils? So it's actually for volume, but it's asking for it in mils. So you're going to have to do a second conversion there. We have a molarity of 0.250. Notice that 0, that's significant. So this is 3 sig figs, because that's at the far right of a decimal place. The only reason it's there is because it's significant. Of sodium chloride. And what do we want? We want a solution with 0.100. These are also significant. They're at the far right. So this is 3 sig figs. Moles of sodium chloride. So we're looking for volume. So I'm going to rearrange this one to solve for volume. Now notice this volume is in liter. So keep that in mind. So first we're going to get volume in liter, and then we're going to convert it into mils, because that's what it asks for. So to solve for volume in liter, I'm going to do this in a different color. So what I'm looking for and what I have are in blue, my focus points. So to solve this, because this is going to be in liter, following this equation, we have moles. There's our moles. Okay, match them up. And you don't have to put the identity there, because we are only talking about one specific solution, and they would cancel out. My molarity is 0.250. Now, if you want to look at units, remember that molarity is mole over liter. That's the unit. And so you can see that my moles would cancel out, and liter would be my unit for my answer. So if you do the math on just this step, the slide does it in one step, but I'm going to break it up into 2. We have 0.1 divided by 0.25 equals 0.4. I have 3 sig figs, 0 liters. Now you have to say, okay, great, but it asks for them in mils. So I have to convert this to milliliters. So put what you don't want on the bottom, put what you do want on the top. For every 1 liter, I have 1,000 mils. So calculate 0.400 times 1,000, and you get your answer, which is 400. 1, 2, 3, yeah, mils of a 0.250 molar sodium chloride solution. Now, we don't know, someone else coming in doesn't know that that is 3 sig figs. So this is just an exercise. Sometimes you will see a dot at the end. That's to imply that it's 3 sig figs. I would prefer writing it with scientific notation, which lets us know that it's in fact 4.00, but that's another lecture. Okay, so we solved for volume, keeping in mind that volume is in liters when we're doing molarity. That's the unit. Once you've got the volume in liters, and as long as, if you write every unit every single time, it will help you keep straight. Right? I have units for everything because we're getting more and more complicated. And so you need to write units and identities everywhere. I didn't write identity here, but I did up here. And then I knew I was using the same thing. But keep critical that you keep your units. So you don't go to write the answer, but if you write what you're looking for, that's your focus. If you go start to write this and you're double checking that, you'll catch that. You're not giving the right answer because that's not the right answer, okay? So double check these things. I'm a big fan of focus point. Strip the numbers away from the words and then go with that. All right, next slide. It says how many moles of calcium nitrate are in 250 mils of 0.150 molar calcium nitrate. All right. What is it asking for? Let me erase my equation here a little bit. And again, we don't, this is not, the little L is not part of the equation. I'm putting it there to help remind you guys that this is in liters. That's the only reason I'm putting it there. So the question is how many moles of calcium nitrate? Remember, nitrate is a -1 polyatomic ion. Calcium is a +2 ion. So we have to have 2 nitrates for every calcium. Are in 250 mils. So our volume here is 250 mils. You need to convert that. With mils, you can just go 1, 2, 3 because it's 1,000. So I know it's 0.250 liter. So, but if you're not sure, go ahead and do the, you know, convert it. Right? And when you do this, you will get 0.250. Okay. And our molarity is 0.150 molar calcium nitrate. Initially, you have to have 2 of the unknowns to get the third. Now, in later questions, more complicated ones, you will probably have to take a couple of steps to get the 2 unknowns. But right now, we're going to keep it simple. We're going to give you 2 of the unknowns you solve for the third. So if I'm going to solve for moles, I'm going to rearrange my equation. It's molarity times volume. That is a V. Remembering that its volume is in liters. So can we solve this? Just plug and play. Our moles of calcium nitrate. Molarity, I have 0.150 moles. And again, if you want to think in terms of units, this is moles per liter. That's the unit for molarity. And it's fine if you want to put that in instead. Times volume. I've converted my volume to liters. I did not drop my 0. This 0, I'm going to assume is important because this is 3 sig figs. Right? So then when I do this, these liters will cancel out. Mole will be left over. and you end up with 3.75 times 10 to the minus 2 moles of calcium nitrate, which is 00375, right? Did I live 1, 2? No, it's not. 03751, 2. And so we rewrite it in scientific notation. And then if I'm making this in the lab, I will now do a conversion from moles to grams of this. So that's what I go weigh out. I put it in my flask. I bring the water up to 250 mils. Voila, I have my solution. So this is real world stuff. We do this all the time. Okay. So the next one, strontium nitrate, not commonly used. But I guess it makes a good question. So it says how many grams of strontium nitrate are required. Now, all right, now this goes right back to what I was just saying with the previous example. How we take that mole and then we actually convert it to use it in the real life. So the question is, how many grams of strontium nitrate do I need to make a volume of 250 mils? This time it gives me another 0. And a concentration of 0.100 molar strontium nitrate. Okay. Once again, we're in mils. That has to be converted to liter. And so that's just move this 1, 2, 3 this way. 0.2500. Do not drop that 0 liters. 4 sig figs. This 0 is on the right side of the decimal. There's no other reason for it to be here. There's nothing around it. So it's significant. Same with these two. All right. So we want grams. Well, we can't get to grams directly, right? Our equation here doesn't solve for grams, but it does solve for moles. And you know you can get from mole to grams. So we're going to rearrange to solve for moles. That's a times. So let's do that first. So the moles equals molarity, 0.100 moles. And again, if you want to use unit, the unit for this is moles over liter. So you can see how it cancels out. Our volume is 2, nope, see, I almost wrote it wrong. 0.2500 liters. I don't know why I put those in parentheses. So the liters will cancel out. You will be left with a unit of moles. And the answer is 0.0250. I'm off the board. Moles of strontium nitrate. Okay. Now, this is 3 sig figs. This was 4. We're multiplying, so we use the 3 sig figs. This 0 does not count. It's a placeholder. I can rewrite this in scientific notation as 2.50 times 10 to the minus 2. Get rid of this 0 and not lose any data. This one is significant because it's on the far right. The only reason we have it, it's on the far right of the decimal, is because it's significant. So 3 sig figs, 3 sig figs. But we need grams. And you know how to do this. So we just simply use molar mass. Mole down here, grams up here. For every 1 mole, there are 211.62 grams. And that will equal, again, 3 sig figs, so it's 5.29 grams of strontium nitrate. So I now know I can make this solution in the lab. I will go to my scale. I will weigh out 5.29 grams. I will put it in my flask, my graduated cylinder actually, not a flask. I will bring the water volume up to 250 mils. Shake it, make sure it's dissolved. There you go. I have my 0.1 molar strontium nitrate solution. Okay. Now, this next one, I want to show you the slide because it's got this blue bar on it, and I want to show you what to do with it. So we'll go down well, here we go. This one, these are ones we just worked through. Again, I'm in the 8C. That's talking about how you prepare solutions. This is called a volumetric flask. See that little line? That little line, a volumetric flask will make a volume of one exact measurement only. It's extremely precise. So depending on what you're making, if you're just making a sodium chloride solution, for example, something not real critical, you can use a graduated cylinder. But if you're making something where being exactly precise is important, especially let's say you're doing a medicine or toxicology or trace analysis, where it does matter. That line will give you exactly, usually to the 2 decimal place, the volume that you're measuring. And they come in little teeny tiny adorable, 10 mil volumes to 1 liter is the most common, half a liter. So when you're using this, when you get towards almost the end, you use an eyedropper, because if you go over that line, you kind of blew it. You can't remove any liquid because it's already a solution. Because it goes to the neck and goes right up there really fast. So if you ever use one of these, you put your volume into most of the way and then use an eyedropper or a pipetter to go to the last little bit, and then you upend to mix. So that's a volumetric flask, and it's a very, very precise measurement. I'm not sure what's going on here. Okay, that's just a side thing. The little ones are really adorable. So this slide, if you look at this in, if you have this up in slideshow format, you can't do anything about this blue bar. But if you pull this up and it's in just this mode with the slide showing on the side, you can move it. All right, so I'll work through it, but when you look at it, know that you can move these blue bars if you're in this mode. So I'm going to work this one out, and then we're going to talk about how to make a dilution. And that's a different equation, but it's actually very simple, and it's one of my favorite equations. It's so extremely useful. All right, so let's go back to the whiteboard. But for the moment, we're still doing using molarity. And the question says, how many grams of potassium, I think this is permanganate, must you weigh out if you want to make 250 mils? So my volume is 250 mils. It does have a dot after, which tells us that 0 is significant. It's something, I'll be honest with you, I never saw when I was learning chemistry, but I had a student show me. I need my unit. And the concentration is 0.200 molar potassium permanganate. Okay, we have to change this to liter. I've done the same number twice already, so I'm just going to rewrite it. 250 liter. Okay, so what do we have? We want grams. We can't get to grams directly with this equation, but we can get to moles. And of course, once you have moles, you can convert to grams very easily. So I am going to first solve for moles, which is my molarity times my volume in liters. I'll use purple. So my moles of potassium permanganate will equal molarity 0.200. And remember, this is, if you want to use the unit, this is moles per liter. That's the unit of molarity, if you want to cross things out, times my volume in liter. If you use your units, if you write this and you accidentally write mils over here, you will see that it does not cancel out and you'll catch it. So that might help you. That's a point. So my liters will cancel out. I will get moles. And let me do the math because the slide does it in one step and I'm doing it in two. Excuse me. 0.2. I know I should be able to do this in my head, but I'm going to be lazy and use my calculator. Equals 0.05, but I have 3 sig figs, 0, 0, right? That's 1 sig fig. I have to add my zeros to make it 3. Moles, potassium permanganate. But of course, I have moles. I want grams. That's what the question is asking for. So we do what is by now very familiar to you. And the slide, if you lift up that blue bar, shows us. Although I would recommend, if you take the time to make the molar mass of this, it's really good practice. And then you can look at the slide to see if you got it right. So I recommend you actually calculate that out for yourself and then check and see if you got what the slide says. Moles will cancel out. And your answer is 7.90 grams of potassium permanganate. So now I go to my chemistry cabinet, I pull this out, it's a solid, I weigh out 7.90 grams, I put it in my graduated cylinder or a volumetric flask, depending on what I'm doing with it, how precise I have to be, bring my volume up to 250 mils. And I have my solution. So that's how we use, and again, we do it all the time in the lab. 3 sig figs, 3 sig figs. So my sig figs are correct. Okay, the next, now we're going to move on to dilution calculation. And it's very straightforward and it's very handy. So these so far have been how you make a solution from a solid or a liquid, from a starting pure stock, right? But oftentimes, if there's something we use a lot, we will make a concentrated version of it that you then make dilutions from. It just saves time, because if you're constantly making your 1 liter of a solution at the normal concentration that you use all the time, you run out of it really quickly. So we'll make what's called a 10x, sometimes even a 100x, but the 10x is most common, or 50x. That means the concentration of that stock is 10 times what you're going to use. So if I use a 0.5 molar sodium chloride all the time, I will make a 5 molar stock, and then I do 1 to 10 dilutions of that throughout the day as I need it, and it's just much faster. I'm not having to stop and redissolve sodium chloride and go through all that. I just measure out, if it's a 10x, I measure out 10 mils of my concentrated and bring it up to 100 mils, 10 times. 100 mils, bring it up to 1 liter. So I measure out 1/10 of the stock solution and I bring it up to, so we'll just show you. So this uses initial and final, but I use 1 and 2. You also will see this with C for concentration. It's the same thing. It's M1V1 equals M2V2. Again, I use 1s and 2s. C1V1, C2V2. It's the same thing. you are going to have 3 of these numbers. You're going to solve for the 4th. So I'm looking for, okay, so we will work through a couple of these as well. But I will start with my, my 10x that I was talking about. So back to the whiteboard. So this is, like I said, lid. There it is. M1 V1 equals M2 V2. Now, a couple of things. It doesn't matter what you call 1 and what you call 2. What's happening is, what's my concentration? It's mole over liter times a volume. That's the number of moles. So if you take a volume, it has a certain number of moles, a certain amount of particles, a certain amount of stuff in it. And you change the volume, right? Here's L1, L2. This is just showing you how this works. If it's confusing, you can forget, you can ignore this. But what happens is when you cancel out your volumes, your mole is the same because you have not changed. When you pull up a pipette with a certain amount of, let's say, sodium chloride in it, and you put it in another flask and you add more water, you're changing the concentration because you've diluted it, but the same number of moles of sodium chloride are still there that you had in your pipette in your new flask. And so that's what this is showing, is that you can change the volume, but what you transferred, the number of particles of sodium chloride or whatever, are still the same. So that's how I think of this. Okay. So in my 10x example, well, that won't really work, will it? All right, well, we won't be using 10x and 1x, but we'll just go ahead and go with the slide. I'm afraid if I try to use the 10x, I might get confused, make it confusing. So the slide says what volume. Oh yeah, in mils. This is the other thing. Because your volume units cancel out, and I'll show you with this first example, this is the only time you do not have to change this volume to liter, because they're going to cancel out, and I'll show you. So this, you do not have to change your volume from mils to liters. If it's mils, you can keep it in mils because they're going to cancel out. If you work a few times, you'll see this. So my question here is, my glue is already running out. Volume, and it specifically says in mils, of 16.0 molar sulfuric acid must be used to prepare. So this is going to be my first set of volumes. I'll call it V1 because we're looking for V. Like I said, it doesn't matter which one as long as you keep the numbers in this with the proper, your proper volume with your proper molarity. And you're going to prepare 1.00 liter of 2.00 molar H2SO4. So this, remember the previous slide showed initial and final, and you can do that too, M1 or MB initial and final. So this is my initial. I'm taking from this and I'm going to make a dilution. So first, let's just, here's something I'm going to rearrange this to solve for, I've called this one V1. So I'm going to solve for V1, doesn't matter. I always write this every single time I do one of these dilutions, and I do a lot of them. I always start with this. as many years as I've been doing research, I still start with that and then I rearrange it because I get confused easily. So do not feel like you should already be able to rearrange it in your head. Many people do. I don't. So I'm going to solve for V1. So I'm going to rearrange my equation like this, okay? So now let's plug some numbers in. M2, because I'm calling this V2, so that's M2, 2.00 molar times my V2 is 1.00 liter. My M1, what I'm starting from, right? And now you see these molarity are going to cancel out. Now this is going to give me something in liters because that's what I was initially given. So be careful because the question asked for mils. So when I just solved this one, and this is another reason why you always write your units, this is equal, I'll write it down here, 0.125 liter, because it's asking me the volume. Because you're going to make a new solution that's 1 liter. This is the concentration you want. So you need to know, well, how much of my stock do I use? Do I add to make it 1 liter? So this is how much of your stock you add. But you're going to do in mils. So you convert this liter to mil, 1,000. Or you might be comfortable with it now to know you just move this to the right 3 times. So you are going to measure out 125 mils of your 16 molar sulfuric acid. And you're going to put it in a container. And because this is acid, we always add acid to water. You're going to put it in a container with about 800 mils, because this is 1 liter, 1,000 mils, about 800 mils already in it. You add your 125 mils of acid carefully, keep away from the vapors. You will see it swirl down in there. It's kind of cool because acid's heavier. And then you will add water until you reach the volume that you're looking for, which is 1 liter. So that's how you make an acid solution, a diluted acid solution, is you have mostly water, add your acid, do it in a hood, it'll smoke. And then you finish off with the water you needed to make 1 liter, which in this case is your volume. So your volume and your concentration are on one side, and the whatever you're looking for is on the other side. Okay, let's go to the next one. Again, this one has a blue bar. The next 2 do, so remember you can remove that blue bar. But this is just the best equation in the world. So it's asking for what volume is needed of 12.1 molar HCl. So that's my stock. It's a very concentrated stock. Is needed to create 250, there's a dot there, mils of 3.2 molar HCl. So that's your dilution, right? You're starting with a stock of 12.1. You want to make a working stock, a working volume of 3.2 molar. You want to make 250 mils of it. That's what you need for the day or the week. So how much of your stock do you need? Okay. Again, it doesn't matter which one you call V1, V2, so just do that. I'm going to rearrange my equation. I'm going to solve for V1. Right? My V2, M2 are over here, so 3.2 molar times 250 mils. It does not matter that this is in mils because I'm going to use mils. This is the only time you don't have to, when you're using this equation, you don't have to convert. So my starting molarity is 12.1. Remember, you are going to have 3 knowns and 1 unknown. So you're going to know this, this, and 1 of these, or this, and 1 of these. And I plug it in, I do the math, and my V1 is equal to 66 mils. Now, this is 3 sig figs, but this is 2. So my answer will be in 2 mils. So I go to my graduated cylinder or my volumetric flask, whatever I'm using, whatever my precision needs are. I'm going to make 250 mils. I'm going to put 150 mils of water in there because I need to have plenty of room for this. I'm going to, in the hood, it's going to vapor. You don't want to burn your lungs and your nasal cavity because the vapor will burn you. So you go to the hood and you add your 66 mils to your water. Now you take, and we're using a small beaker or dropper, whatever that fits your needs. You bring your water up to your volume up to 250 mils. So that's how you make this solution, this diluted solution. Because you have an acid, you have to put acid in water. Acid is heavier. So you put it in you put your water first and you watch the acid go down. It's kind of cool. Okay, so that's how you are going to make this dilution from your working stock. Okay, next one. So what do we have? We have 25 mils. So there's a volume of 6.0 molar HCl. It's diluted, so we have a new volume to 500 mils with water. So this time we're going to be asking for what is my molarity? Okay, again, it doesn't matter what you call, so we'll call that M1 and we'll call that M2. So this time I'm going to solve for M2. So I'm going to rearrange my equation. M1 V1 over V2, because otherwise I will get confused and put things in the wrong place. My M1, I like changing colors to do this. I'm going to put this in green. So my M1, my molarity is 6.0 molar. My volume is 25 mils. Again, I do not need to change it, and here's why. My volume 2 is 500 mils. My volumes are going to cancel out. That's why you don't need to change in this equation only, because your volumes cancel out. Or the volume you get, you can convert yourself. If I do my math, this is 2 sig figs. I don't know. I'm going to assume this is 3, just because the way the answer is given. I get 0.30 molar. So this time you made the dilution. Maybe when you were making it, you accidentally added the wrong amount of HCl. You meant to add 20, you accidentally added 25. So you need to know, what's my new concentration? Can I still use it? Can I work with it? So you do this calculation, you find out, okay, it's a 0.3. I wanted a 0.25. You can probably still use it. Depends on your specific circumstances. So this is how you calculate what's my final concentration. If I know my initial volume or my initial concentration, the volume you removed from it and added for my new volume. M1 V1, M2 V2. You just plug and play. I'm looking through. All right. There are a few more. You might want to pause and then come back to this because I know it's a long one. So this is specifically answering stoichiometry questions. again, I'm continuing down the slides. Oh, all right, no, that's acid base. We're not going to do that yet. Okay, the last set of slides in this subject have to do with acid base and titrations. So when we talk about neutralization, these things, we're going to get to that next week. And so that's when we'll work out this set of problems. So I will stop this here. You've gotten a lot of great examples to work with. And then again, any questions that you have, you know, send me email or meet for office hours. But it's just, you have those, often you will use those two equations together. The molarity, let me go back to whiteboard a minute. So I'm going to erase the L because this is what you normally see this as. This one, that's more for when you learn the titrations, you're going to use these together. So initially it's going to be mostly this one. These two equations you're going to be using together, and then when we get to titrations, you will be including this with this to help you find. Sometimes you have to go through this step to find the molarity, and then you use the molarity here, or various combinations of. But generally, these are the three that are used together. And so you rearrange. If you need the mole here, maybe you need to use this to go from grams to mole, to plug in, etc. Rearrange them as needed to get just to, you know, if you write down what you're looking for and what you have, then you can look at the what I'm looking for and say, okay, can I rearrange this to get that? And usually the answer is yes. And so if you, again, you do this a few times, it will start to come together. It's kind of a puzzle, and really they're kind of fun. Think of it as a puzzle. And, you know, please ask questions if you get stuck on something. Okay, you guys have a good day.